By now you might be getting the idea that there are no original ideas in architecture. This isn't entirely true. Until the 19th century, architects usually chose from limited building materials ranging from wood, mud, brick, and stone. The Industrial Revolution, however, first introduced large quantities of iron and glass into buildings. The use of iron and glass revolutionized traditional construction methods, allowing great feats of enclosing or traversing space. The use of these techniques spread from factories, warehouses, and train sheds to commercial buildings and monumental works like libraries and train stations. Webs of iron and glass could be employed to create large covered galleries. Lightweight systems of spanning with iron proved cheaper, stronger, and more fire-resistant than stone or wooden methods. Tension also became a new big factor in large-scale designs, best seen in suspension bridges or railways. Metal in buildings had, since the ancient Greeks and increasingly in the early 19th century, been used for structural support but remained hidden as a supplement to structure, and occasionally bronze, copper, or lead served as roofs. Most architects found exposed iron in this time very unseemly, but it proved cheaper than stone and more resilient. It could withstand fire better than wood. The casting process allowed for prefabricating iron components in bulk that could be shipped to a site for assembly, so iron soon became a very desirable option to experiment with because it was light, strong, and relatively fire resistant. The first non-industrial iron and glass buildings were, you can imagine, garden hothouses or greenhouses in France and England, which were built during the early 1800s. But very soon another type of building appropriated spans of iron and glass coverings like greenhouses, which became very widespread first in Paris. This was the shopping arcade or passage. It was a ferriture structure that shielded long blocks of shopping and cafe districts from the elements to present this pristine, continuous display of windows all year round. The first shopping arcade, the Passage du Car, opened in 1798, designed by François-Jean Delannoy. It inserted a pedestrian path through several blocks to provide fronts for small, locally owned shops and boutiques, designed in the neoclassical style. By the mid-1800s, the trend had boomed and Paris had more than 150 shopping arcades. The first covered shopping arcade that can be considered a great work of architecture and art was the Galerie Vivienne. It was built within a hotel as a truly elegant shopping atmosphere for high-end stores, wine shops, tailors, bookstores, high fashion stores, furniture stores, and restaurants. It featured classical facades, patterned mosaic pavements made of marble, arranged in these intricate geometric patterns that create a sense of depth and movement, and overhead glass and metal roofs with a central glass cupola or dome in the center of the center. It is adorned with ornate cornices, frescoes, and friezes and gilded sculptures. The walls and ceilings are painted in soft pastel colors which provide a subtle contrast to the intricate details of the mosaic floors. So the glamour of these arcades promoted consumerism. These Parisian arcades generated copies throughout Europe and the Americas. In Brussels, Jean-Pierre Clousonier created the Passage of St. Hubert, inscribed with the motto Omnibus Omnia, Latin for everything for everyone, over the entryway. Just like in Paris, he spanned these wide halls with these massive glass barrel vaults. So many considered arcades the very emblem of escapism and consumerism, and that they contributed to an illusion of well-being within the modern cities. Parisian arcades began to lose their importance in the 1860s with the appearance of the first department stores. Now the variety of merch scattered in the arcades was gathered into a single grand masonry envelope under a central top-lit atrium space. It was a church to consumerism. The Aubin Marche store, built by Boileau, opened to 4 floors of balconies for shoppers to display themselves. The department stores built in Italy were built at a greater, much more open scale, many of which still survive today. The Galleria Vito Emanuele II in Milan, begun in 1863, covered a 4-block area connecting the city's 2 major public spaces. It was a cruciform plan of vaults culminating in a central glass cupola over the crossing. The Galleria featured 2 levels of retail, 3 office spaces, and residential units, all fronted with a very Baroque style. All the major cities of Italy built their own version of Milan's Galleria in order to participate in this new expression of national progress. The Galleria was larger in scale than its predecessors and was an important step in the evolution of the modern glazed and enclosed shopping mall, of which it was a direct progenitor. It has inspired the use of the term Galleria for many other shopping arcades and malls. While the Milan Galleria was very impressive, it was only a masonry structure with a glass roof. The idea for a completely transparent iron and glass structure in and of itself originated in England with the architect John Claudius London, where he popularized the design of glass-covered iron vaults through numerous pamphlets. In London, he created a two-tiered dome of the Palm House at Bretton Hall in 1827 to provide a large open space for growing and displaying exotic plants such as palms, ferns, and other tropical species. The dome allows for ample sunlight to enter the space while also providing protection from the elements. The low outer ring of masonry and interior circle of cast iron columns supported the bell-shaped dome, ideal for even distribution of heat and for symmetry and beauty. The wrought iron sashes were inspired by nomadic tents. He supplied steam and heat to create a tropical atmosphere from a hypercaust system that vented through reveals between the upper and lower vaults. Joseph Paxton copied Loudon's hothouse plans to build a great conservatory at Chatsworth in 1836, which took the record as the largest glass building in England at the time. Instead of a central plan, he extended the bell shape essentially to a rectangular basilica plan and developed a more sophisticated roof using pleated glass formed in a chevron pattern to strengthen the structure, to channel water runoff, and to resist perpendicular rays of the harsh midday glare while magnifying morning and evening sunlight. Cast iron columns of the interior doubled as hollow drain pipes to collect water. The building housed rare tropical flora like orchids, banana trees, and palm trees brought back from colonial India. In 1849, Paxton built a second hothouse with straight-up walls to protect a giant Victoria Regia water lily from the Amazon with a heated pool and spinning water wheels using steam power. Here he further developed his structural techniques, where he was able to build a flat roof with his ridge and furrow glazing and a vertical wall system that allowed glass to hang from arched beams. Then, the record for the largest glass building was one-upped yet again. The Palm House, built at Kew Gardens, used Loudon's method on a much larger scale, and the fact that it's still standing today testifies to its durability. These are lightweight structures, but they are by no means fragile and in danger from the elements. These are made of reinforced iron and thick industrial panes of glass. To build this took 200 tons of iron and 1,600 panes of glass. No one had even built a glass house on this scale before, and to do so, Decimus Burton, the architect, borrowed techniques from the shipbuilding industry. The Palm House is essentially the upturned hull of a ship. It was an engineering wonder of the age. Its purpose was to provide a home for the tropical plants that Victorian explorers brought back from their adventures in the tropics. It was made so that conditions could be perfect for wet zone plants. It's warm, humid, and gets plenty of light so that seeds that explorers brought back from the tropics could grow very fast and be admired by friends in a short span of time. These hothouses are so tall because the exhibitions of these gardens, the palm trees, can grow up to the ceilings, creating the feeling of being in a jungle canopy before they need to be cut down. It wasn't long before Joseph Paxton got back at Burton for one-upping him. Paxton's hothouse experiments would serve as prototypes for the most innovative, very vitreous structure of the century, and largest yet by far, his palace for the Great Exhibition of the Works of Industry of All Nations in 1851 at the World's Fair in Hyde Park, designed to house a year-long celebration of the British Empire and exhibition of the many cultures it had influence over. The concept behind the World's Fair was brought about in 1850 and considered the display of cultural items and aspects from many nations that fell under British rule. It was essentially a propaganda fair promoting the British Empire for its citizens and foreigners to travel and see and be impressed. It was proposed by a commission of influential men and would be funded by public subscription. Having enough investors, the commission issued a competition to various architects to design the building. The building had to be temporary, as cheap as possible, and buildable before the exhibition opened in a year. Joseph Paxton had, by this time, earned great renown as a garden house designer and was chosen as head architect. His original concept drawing shows that he decided to expand upon his design for the Lily House at Chatsworth with straight walls and a flat ceiling, and he largely stuck to the initial idea. The budget of his design was remarkably under the limit despite promising a footprint of 77,000 square feet. He was able to complete the world's largest glass structure in less than a year and significantly under budget. Shortly after building began, he added a high barrel vaulted transept across the center of the building to safely enclose several large elm trees that would have otherwise been cut down. He used his patented pleated glass on the outside and roof of the building to keep it from absorbing too much heat from the sunlight and to strengthen the structure of the glass immensely. Additionally, there was an initial concern that flat roofs might shatter under water weight from rain, but Paxton designed a ridge and furrow roof with efficient drainage, with water running off the angled roof panes into cast iron gutters, which ran the length of each roof section. This gutter structure supported rails and carts on which builders sat as they installed the roofing, speeding the process exponentially. Paxton also used the structure of the elm trees to serve as scaffolding during construction. It was among the largest structures ever built at the time, longer than the Palace of Versailles and as tall as a Gothic cathedral. It embodies the utilitarian spirit of industry built without masonry, almost built exclusively of iron and glass. Paxton determined the layout of 13,000 exhibition spaces following a 7x3 by 7x3 meter structural bay. The palace took on tremendous thermal gains. Despite vents at the base and the top of the structure, Paxton had to add canvas tarps to shade the palace, especially during hot summer months. To maintain a comfortable temperature inside year-round was in itself a major challenge, especially because air conditioning had not yet been invented. Glass houses naturally accumulate and retain heat from the sun, but this would have been exacerbated by the heat radiating from thousands of people in the building at any given time. To combat this, Paxton designed a ventilation system in which the glass modules on the outer walls could be opened and closed using a complex gear system, allowing hot air to escape. Additionally, the ground floor was raised significantly and was made of wooden boards spaced 0.39 inches apart. This formed an effective passive air conditioning system when the wall vents were open due to differential pressure, causing the hot air which escaped through the vents to draw cooler air up through the floorboards at a near constant rate. Over 6 million people visited the Crystal Palace during its 18-month showing. Most critics recognized it as a turning point of architecture, although it attracted extremes of praise and blame. Joseph Ruskin condemned its brittle, undecorated, classical-like facades, although the palace's sheer size was meant to communicate a sense of honest utilitarianism, an architecture providing the greatest good for the greatest number. Although, since initial tickets were £1, only the upper classes could visit during the first few months. Then they were gradually marked down to include the middle and finally the lower classes. The exhibitions ranged from displays of industrial machines, so turbines, power looms, reapers, to handicrafts from colonial dependencies in India, Australia, and New Zealand. 60 individual countries sent exhibitions of their decorative arts. Augustus Pugin even fashioned his own Gothic display. The palace provided a stage for the prowess of the British Empire, dominator of world markets, vanguard of industry, ruler of huge colonial populations and their own working class. The Crystal Palace even had the first major installation of public toilets. Eventually, the exhibition closed on October 11, 1851, rendering the gigantic palace useless. It was dismantled, but its patrons wanted to save such an impressive structure, so they financed it being put back together on Sydenham Hill in a slightly different layout, with 2 new transepts at each end of the main gallery. From then on, the Crystal Palace served as a museum, displaying a narrative of the history of fine art. Among these was Augustin Pugin's Gothic court from the medieval exhibition. And the central transept was a concert hall for a grand orchestra and 4,000 concert seats. Exhibitions of all kinds were hosted at the new palace for years, from cat shows to early airplane shows. During World War I, the palace was commandeered by the Royal Navy for use as one of Britain's largest training establishments. The trainees slept in bunks in its halls. Toward the end of the First World War, the Crystal Palace reopened as the site of the First Imperial War Museum. On the night of November 30th, 1936, a fire broke out inside the palace and ripped through the structure, causing its total destruction. The glow of its flames were visible across 8 counties. The scale of the fire could not be extinguished despite major efforts, and in the end, nothing survived. It was reduced to a pile of melted, contorted steel. After the Crystal Palace, architects desired to experiment with the structural advantage of ferrovitrous structures, but feared their fragility and insubstantial appearance. Soon, however, there was a new avenue for such architecture. New train stations for the railways in England, the first of which opened in 1825, needed to shield wide expanses of outdoor docking platforms from the rain, yet achieve an inexpensive way of providing light. The first ferrovitrous train shed was built in 1837 by a classically trained architect, Philip Hardwick, at the Euston Station in London. It was faced with a colossal Doric classical entrance inspired by the Propylaea and reoriented the idea of the city gate to a central position within the city. The Great Hall of the station featured a triple-height atrium like a Roman forum with coffered ceilings and set a new standard of luxury and elegance for passenger stations. It was an interesting take to symbolize modern travel with ancient architecture, but classically inspired forms are still widely associated with modern train stations today. This was the first instance of the station hall as a highly decorated classical style with a ferrovitrous train shed, but it soon became the established type. King's Cross Station innovated on this scheme. The many classical arcades on its frieze served as an entrance for passengers, while 2 enormous arch windows traced the shape of 2 gigantic and ultra-modern looking ferrovitrous barrel vaults behind them. The classical front did not attempt to obscure the modern glass and iron structure behind it, but rather be plain and truthful about its futurism in a sea of old-world buildings by inviting one's gaze upward to blend the two, arguing for an awkward yet somehow harmonious marriage between architectural revival and modern functionism. This harmonious disjuncture of components soon became a signature of train stations. St. Pancras Station in London, finished by William Barlow in 1868, topped King's Cross by exhibiting an even more ambitious and extreme disjuncture between its components of architecture. The front of the station, combining a hotel, restaurant, ticket office, and drop-off portico, was designed by George Gilbert Scott in a Venetian neo-Gothic style, with a Flemish clock tower and polychromatic turrets and gables. On the outside, the station appeared as an ancient Venetian fantasy palace, but inside, a long series of unapologetic iron and glass train sheds and platforms branched directly off the Venetian Gothic buildings and were partly supported by them, putting excessive formalism next to excessive functionalism, giving one the sense that the England of the future was an enhancement to its beloved history and tradition. Its impressive wrought iron and glass vault remained for several decades as the world's largest free-span roof. The Eiffel Tower came to exemplify the height of steel construction in this new age of architecture. It's reminiscent of a railroad track or warehouse, yet somehow still very beautiful. How did such a strange structure come to be? Well, France in the middle of the 1800s was in a crisis. The country lost most of its empire in 1870 after its war with Prussia. Morale was low and the country was unstable, so the government proposed a World's Fair event in Paris, just like that in Britain, as a chance for France to regain some status. As the Industrial Revolution swept the globe, World's Fairs were a chance for countries to show off to other countries their new technology, just as England had done with the Crystal Palace. At the center of their fair, in order to top the Crystal Palace and spite England, they set out to build the tallest building in the world at 300 meters within just 2 years. The man in charge of the building was Gustave Eiffel, a French engineer. Eiffel was already famous for metallic structures like bridges, and he even built the underlying iron structure for the Statue of Liberty. Here's his original sketch, an iron tower supported by its own scaffolding and arches. By 1887, this giant project, actually painted red at the time, started to rise up in the middle of the city. Plans adapted as buildings progressed, but eventually Gustav perfected a system of delicate iron webs on masonry foundations, which supported towers of wrought iron girders. It had to be made with a structure of thin iron bars crossed together to allow the high altitude wind to pass through. While it was going up, much of the population hated it. People petitioned against it. To them, it was very strange and industrial and didn't fit in with the atmosphere of Paris. But after just 2 years it was done, and public opinion immediately shifted in resounding favor of it. People lined up to ascend it and view their city higher than they ever had, using unique slanted gondolas. The tower was twice as tall as the previous world's tallest building, the Washington Monument. And once again the world marveled at France. Gustav used the mathematics of steel bridges, which allowed it to be a lot taller than any structure ever built in human history. When originally built, the first level contained 3 restaurants, 1 French, 1 Russian, and 1 Flemish, and a bar. At the top there were laboratories for various experiments, and a small apartment reserved for Gustave Eiffel to entertain guests. As we know, the Eiffel Tower soon became the defining symbol of Paris.